But we're going to start off with Newton's laws of motion. We're going to talk about force. And what force is any push or pull on an object, sometimes causing a change in motion of the object. Okay? So our force, we've got push or pull. Can someone show me an example of a push? Yeah. Oh, look. There. Okay. There's a push. What about a pull? Can someone show me a pull? Okay. There's a push or pull. Pretty simple. Okay, and that's a force that caused an object to move. There's a couple types of forces. We've got balanced forces and unbalanced forces. Unbalanced forces are two forces acting on an object that keep it doing what it's doing, whether it's sitting still or moving. So there are two forces acting on an object to balance. Then we've got unbalanced forces, which balanced forces keep something doing what it's doing. What will an unbalanced force do, Jade? Okay, change it, right? Tilt it over. In fact, Rayana, is that what I said? Okay, can I borrow you for a second? Okay. Would you say that Rayana has balanced or unbalanced forces working on her?
Balance.
Balanced force. What would be a way that I could unbalance her? What could I do to her to unbalance her? Blade, what do you think I could do? Just kick her out. No? Okay, I won't do that. I won't do that. Bree, I could push her. I could make her stand on one foot. In fact, that's a good idea. Okay, what I would like you, well, hold on. I would like you guys to, and don't move yet, I want you to stand up from your chair without pushing or pulling on anything. Okay? So go ahead. Everyone's standing. Okay. So you guys all stood without pushing or pulling on anything. Okay. Sit back down for a second. Rayana, go ahead and stand up without pushing or pulling on anything. Was she pushing on something to stand up? What was she pushing on? Okay. Oh, besides, can you do it without touching your chair? Was she pushing on anything?
No. She was pushing on her feet.
Okay. So she was pushing on the ground to stand up because she wasn't in motion. She was sitting there, so she had to use an unbalanced force, a push, to push herself out of the chair. You can sit back there. All right. So what if you guys have seen a kindergarten classroom?
Yeah.
See those little bitty chairs? Like this one to sit in. What might I have to do to get out of that chair? Push. I don't know if I can push from here. I might have to do something else. I might have to pull on something. So we said we could get her out of the chair with a push, you think? Like this? Okay. So I've unbalanced her, right? Unbalanced force acted on her to get out. Go ahead and sit again. Make sure you're hanging on. Okay. So then instead of pushing, maybe we could pull her out. Pull her out of the chair like that. So, you see how the unbalanced forces work here? Balanced? Unbalanced. Does anyone know what friction is? Raven.
Friction is a force between two things.
Okay, it's between two things. And what is friction, Bree? You got it there. It's between two objects. Okay, can stop another moving object. Duke?
It's when, say you had a car and you press the brakes on it, it causes friction for the wheels to slide so they stop.
Okay. All right. So it causes friction for the wheels to stop. What about is there friction between the tire and the wheel when you're going around a curve? Yeah. What would happen if there was no friction?
Slide.
Slide right off the road. Okay. So friction is a force that resists the motion of an object that is in contact with another object. Look at the bottom of your shoes. Okay. All right. Now, let's see here. Who's got some? Oh, Antonio, come here. I want you to stand here and put your foot up like that. Okay. Jade, come here. You do the same thing. Okay. Now, which one of these shoes would cause more friction against the ground, do you think? Jade's, right. Okay. Thank you very much. All right. Now, what kind of sport would she want to, what kind of sports could you play where you want a lot of friction? You guys can sit down.
Soccer.
Okay. Why do you want a lot of friction in soccer? What are you doing in soccer? Are you running?
You're always running.
Okay.
You have to turn around. You might slip.
Right. So you want friction so you don't slip. Hunter?
Track.
Track. Okay. Yeah. You want running track like races, hurdles, and things like that. You want a lot of friction. What's another sport you want friction in? Caleb.
Football.
What's a sport? Think of a sport where you would want less friction. Fabian. Swimming? Yeah, very good. Swimming. Have you guys ever seen a swimming race like in the Olympics? Do they go out with like a t-shirt and jean shorts on?
No.
Why not? Would that cause more friction? Okay, yeah, they're all like super small or super tight swimsuits, and they're normally like, I don't know if I've ever seen any body hair on swimmers. The guys, they even shave their legs down because they race at such a high level, and hundreds of seconds count. They even like shave their legs so their hair doesn't slow them down in the water. Because hair will cause friction in the water. What about this? Let's see.
Wheelchairing.
Skiing, right? You don't want much friction in skiing. Snowboarding. You guys watch the X Games? Okay. Yeah. They want ice skating's another one. You don't want friction. So some sports you want very little friction. Some sports you want a lot of friction. Okay. All right. Now we're going to talk about inertia. Okay. Has anyone heard of that? You've heard of inertia? What's inertia?
Inertia is like a seatbelt, like when the car stops, so that you don't go forward.
Okay. You're getting close there. You guys got to observe inertia with Lieutenant Egbert, because what inertia is, and everything has inertia. This table has inertia. You have inertia. A flying ball has inertia. And the first law of motion, Newton says, an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by another force, an outside force. Okay? Who's been riding a car and had their mom or dad slam on the brakes? Okay? What happens to you when they slam the brakes on? What is your body? You go forward, right? Okay? And that's because you have inertia. So if you're going at 30 miles an hour and all of a sudden the car starts slowing down rapidly, your body still wants to go 30. Okay? What about, you ever seen people on a bus or a subway and they get on and they grab the little bar thing and then the bus takes off? They go like that? Now is their body moving backwards or is the bus moving forward? The bus is moving forward, but because you have inertia and you're at rest, your body wants to stay at rest initially, and so when the bus takes off, it takes off without you, except for your feet and your hand, and then you catch back up, and then they hit the brakes, and what happens? One of these numbers, okay? All right, so what you need to know about inertia, I'll tear out my label here, is that basically an object wants to continue to do what it wants to do. If it's resting, it wants to stay at rest. If it's moving, it wants to stay moving, unless it's acted on by another force. Okay?
What does that mean?
Okay. Force is, if I threw this ball, what force would be acting on it?
Your
If
hand.
I just, like this. What force? There's a force that acts on all of us.
Gravity.
Gravity. Okay? It pulled it to the earth. Now, okay, is this ball at rest?
Yes.
Okay, how would I get it to move?
Take it.
Okay, I can kick it. So I'm putting an outside force and causing it to move. Now, it looks to me like it's slowing down. Why didn't it just go on forever? I mean, because it was a pretty amazing kick. So what was causing it to slow down? Nolana?
Gravity.
Okay, gravity. What else? There's something else that was causing it to slow down. Lily? Well, it's inertia, but there's forces acting on it that's slowing it down. Friction. Okay, there's friction against the ground, just like your car tires on the road. There's a certain amount of friction. You ever seen those dragsters and the fast cars when they have those really skinny front tires? They're so skinny because they don't, just like the swimmers with hair, those skinny tires have less friction, and they have big ones on the back, the drive wheels, because they want a lot of friction, okay? Skinny ones on the front so they don't get slowed down, big ones on the back so they can go fast, okay? All right, we're gonna do a little experiment here. Oh yes. This is our inertia apparatus, okay? Some people call it a broom. It's cardboard. Okay. All right, what we've got here, we've got a beaker. We've got a normal piece of cardboard, custom made for this experiment. And we've got a gram weight. Fanta, will you help me? Come on here. Oh my gosh, don't look so excited. Oh, you're one of Charlie's Angels. The all-girl group. You guys see that? Nice. Come on.
There's about 40 people that would love to do this.
Yeah.
All right, here we go.
Excited.
Okay. What Fanta's going to do, she is going to stand on this broom. Yeah, you are. Come over here. She's going to stand on this broom and she's going to pull it back and she's going to let it go and hit our apparatus. And I've got our cardboard hanging just over the edge of the table and our beaker's in just a little bit from the edge and then our gram weight's on top. What do you guys predict might happen? Bradley, what do you think's going to happen?
The broom's gonna hit the cardboard, and the gram weight's gonna fall into the
What's going to happen to the cardboard?
It's gonna fall.
So the cardboard's going to come out and the gram weight's going to fall in here. Does anyone else think something different's going to happen? Sammy, what do you think?
I think both of them are gonna fall from.
Okay, so the cardboard and the weight are going to fall off the front. Okay. Bree?
I think the weight of the cardboard's gonna fall off, and the cup's gonna fall over.
Okay, so the weight and the cardboard are going off and the cup's falling over. All right, one more. Diana. Okay, so when it hits, the gram's going to fall and the cardboard's going to move. Okay. All right, we're going to test this. Get it lined up. Okay. Stand on the brim. Keep it on the left side. All right, pull back there. Okay. Whoa, whoa, whoa. Easy now. Go ahead and put your foot on there again. Okay. And hold it right about there. There we go. Okay. Okay. You used a lot of force there. We're going to try this again. Okay, so one there is correct. It's going to hit, everything's going to, did anyone say everything was going to go flying? Oh, good job, Bree. So everything went flying. All right. We're going to use a little less force this time. All right, okay. All right, go ahead and okay, go.
Oh!
Yeah! Okay, thank you very much. You can grab my cardboard, hand it back, and then go sit down. Okay. That was what was supposed to happen the first time. This is science, so it doesn't always work.
You used too much power.
Yeah, too much. Okay, what was our outside force?
The
What
broom.
was the, okay, the broom. The broom was our outside force. And what did it set into motion? It set something into motion.
And the weight.
The cardboard, okay, so the cardboard went flying. But the weight stayed in place first and then fell. Why did the weight fall in the cup? Why didn't it just sit here? Is there any other forces at work? Fanta?
Well, it's because the weight is heavier than the cardboard.
Okay. But why didn't it just float there in the air? What force was acting on it, Jacob? Gravity. Okay, so as soon as the cardboard was gone, the gravity pulled it down to the cup. And it was gravity that was holding it to the cardboard. Now, why do you think that cardboard was able to shoot out from under the gram weight and not take it with it? What do you think? Wilbur, why do you think the gram weight didn't go with the cardboard? Look at this. Why do you think it didn't go with the cardboard? Is it slippery? So it didn't have very much what? Friction. So there wasn't very much friction there. All right. So that's a now. What if I pulled up one of these carpet squares? probably get in trouble for it. If I ripped one of those carpet squares up and used that instead, do you think that it would slide out from under the gram weight? No, there's more friction. Or a piece of rope. If I took the bottom of one of your shoes and put this on, it'd probably what? It'd probably go right with it. Okay. So because we had less friction here, and the outside force hit the cardboard, it was able to set it in motion and slide right out from under the weight. All right, pretty cool. You guys will get to one of your Newton stations. You'll get to do a small version of that inertia app. This is Tony Hyde. This is my reflection on classroom management for my mini lessons that I taught. I'm going to talk a little bit faster than I normally would on this because I'm trying to save time, because my video is a little long and I had to edit some of it out on my lesson because my lesson ran a couple minutes long. So you'll notice that you probably did when you watched it, a couple little choppy transitions, just because I had to edit it for time. Number one, objective, discuss how you planned for any anticipated behavior issues and how you implemented that plan during the lesson. Okay, I planned for minor behavior issues like, talking out of turn without raising your hand, excessive talking in a group, and things like that, by addressing that right up front with the students, what I expect from them. And and if we're in a group discussion and I need your attention, I let them know how I'm going to do that. And this group, absolutely no problem. I didn't even have a student in this group, blurting out answers, which is crazy. It was really a great group of kids. I always plan for students that with excessive energy, that are disruptive. I try to have, come up with tasks available to them, like, turning off the lights so we can see my PowerPoint better, or bringing me something that I need to, helps keep them moving and being part of the solution rather than off there moving around, creating distractions and problems. So that's something but I didn't have behavior issues in this class at all. So I really didn't have to implement anything like that. Number two, discuss the classroom management challenges that arose and how you handled those. The only classroom management problem really that arose is my pacing. I run long, and I'm working on that. In the video, there was like really two mini lessons in that: the balanced and unbalanced forces and inertia, and we actually went on to do force equals mass times acceleration, and then equal and opposite action reaction, which I ran over on all those a little bit, so it put me like 10 minutes total over what my time limit is. So, and I did my student teaching last semester, so I'm well aware of the snowball effect of running over. So what I've done to correct that, I set a timer for myself, which has really helped a lot, keep me on track. It's my run in my mouth timer, as I call it, because it seems like I could talk about each one of these little mini lessons, could be an hour long. There's to really hammer in what they need to know and make sure that students have a good grasp on it. So my pacing is something I definitely have to work on, but I've set a timer to try to help myself do that. Number three, discuss how you will change your approach in the future lessons based on what you learned from this teaching experience. I don't feel that change is the appropriate word there. I think more like tweak. I think my classroom management is pretty good. I mean, I did my student teaching last semester. And I've getting some experience now doing this. I think I'm getting a lot better. I know there's a lot of things I can do to change. One thing I've noticed is my questioning needs improvement. When I'll ask a question to a student, and if they're not really right on, I've noticed, especially watching this video, I dismiss it. I'll say, "Well, not quite," and I move on to another student's answer, and I realize what I should be doing is probing a little bit more and guiding that student who's offering input to kind of move them more in the right direction, or at least come back to them after we've talked a little more, with the other students, and make sure they understand. So I think that's, probably the best thing I can do. I hope you enjoyed my lesson and my reflection. Have a